Hi, everyone.
Hi there. Happy to be here. We're very happy to have the chance to travel to Amsterdam. We're from Munich, and to connect to like-minded techies from Amsterdam and other cities. XCOM 2023 is a great chance to share what we've been working on the last couple of, months, but since beginning of 2022. It's a joint project from BMW and Thoughtworks. And long story short, we have been building a machine learning platform for data scientists. So at the beginning, we just want to give a short intro, like, okay, where have we been before? What was the context before we have built the platform? Why are we building it? And then, first of all, okay, what's the features from a user point of view? The user is the data scientist who's using this platform. Then we want to dive into the architecture, which might be more interesting to architects and DevOps engineers, or I don't know, product owners, who knows. And then also, it's not only about throwing a platform over the fence and expecting other developers to just pick it up and use it, but we need product management, right? We need to have product owner and some measures and stuff in place, which we will share about.
Right. So the first section of our presentation would be about the context of the connected platform in BMW's AI strategy. In that regard, BMW positions themselves not just as a premium-priced vehicle manufacturer, but also as a mobility services provider. And with their shared driving pleasure tagline, the company seeks to leverage hundreds of petabytes of data their vehicles already observe and produce to improve their driver's experience. And for that, they naturally use machine learning. And the first group of services to get enhanced by AI and machine learning are digital services. In the next slides, we're presenting a simplified user journey where customer, conditional on their consent for data processing, their data gets collected in the cloud, and then data scientists responsible for developing offerings of either smart maintenance or intelligent personal assistant. They get enabled to automate and develop their machine learning logic so that they can, in a timely manner, introduce or reach out to the customer to offer proactive care, for example, via such channels as My BMW app, email, phone, in-vehicle, and also the usual service appointments at BMW workshops. And as Lena already said, our immediate customer is not the end customer. It's the data scientists that are responsible for enabling that machine learning journey. And the challenge that we faced in this regards was to balance product thinking versus platform thinking. And usually data scientists have their solutions in mind because they have experience outside BMW or even in their BMW departments, where they were already used to some tools. But it was kind of against this platform thinking because we just can't enable all the tools for them. We're looking for synergies. We are also trying to promote best practices and embed them in the tooling that we are providing in this big ship to the right. And that's actually only like the first challenge. And the rest are also the need to hide infrastructure complexity for data scientists because we want them to focus on their machine learning logic. We also want to enable international deployments of machine learning applications, for example, to China, with ever-changing regulations there. Like I said, those use cases are not only heterogeneous in the tooling that they're using, they're also heterogeneous in the machine learning applications they're working on. For example, one use case is interested in providing timely recommendations to the driver, and others are interested in identifying quality defects early on, or any other unforeseen car quality deviations. And that also implies different backends that they connect to deliver results. We address these challenges partly by taking over from the platform of microservices in the AWS cloud that was already developed and heavily used within BMW to have a base infrastructure in AWS cloud. And this base infrastructure handles logging, monitoring. It also ensures backend connectivity. And importantly, it allows for extensions.
Okay, so actually at the beginning, I forgot to ask whom we have in the room, because in the next couple of slides, we're going to talk about the set of features that we're providing to the data scientists. So of course, I'm interested, do we have data scientists in the room? Okay, and then the other rest of people, like data engineers. Okay, great, cool. And then product owners. Nice. Okay. Yeah, I think we have a very great set of people. And also, in your company, is there already such thing like a machine learning platform? Okay. Yeah, I know. For you. Okay. So not that many. Great. So yeah, what we want to do with the machine learning platform, or what we are already doing, is to support the data scientists along their way. I mean, it's very basic. These kind of steps, you know them. You want to pull some data from a data source or multiple data sources. You want to be able to process them. And then, you want to do some exploratory data analysis. Maybe that you already need Spark. If you're not only working on subsamples, but you want to use all your data, who knows what you have in mind. And then once you have some more confidence of your stuff that you're having in Jupyter notebooks or somewhere else, you want to put them into proper pipelines so that you can regularly train your model. And then when the time comes, you want to deploy it and also monitor the quality and everything. And then along these steps, we have different components and features that make together our machine learning platform. So first of all, at BMW, it's obviously very important that you can have access to the vehicle live data, which you can see on the left-hand side. And then also on the right-hand side, we also have the Cloud Data Hub. It hasn't been provided by us, but from the central IT department. But we, from the Connected AI platform, are making up all the connection to this Cloud Data Hub, where they can pull all the historized data, so they can choose between the live data or the historized data, which is very important and the basis for all data analysis. And then what we have chosen as a main tool is Kubeflow. It's Kubernetes native. We knew, we already have all those Kubernetes clusters. So it was crystal clear for us that we want to have something that's well connected with Kubernetes. And also we do like the Kubernetes cluster. They are on EKS on AWS. But still we wanted to have sort of a hybrid approach. Kubeflow is open source, but we can use it in combination with some managed services from AWS, which is pretty handy. And also, we were a set of data engineers and DevOps engineers. We didn't want to have dedicated front-end engineers, or we didn't really have the capacity for it. That's why Kubeflow also came in handy, because the UI that you can see here, it's out of the box. What can you see actually here? Like on the left-hand side, it's the menu. So there, the people can choose the functions or features they want to use. For instance, Jupyter Notebook, or they want to access their pipelines and runs, or their model servers, their exposed endpoints. And they can also, choose the namespace. I'm sorry, I think it's not super sharp, but I hope you can still understand what it's about. Okay, so one of the features, for instance, at the very beginning, you don't right away start with your production grade pipeline, but you first just pull your data into your IDE. And at BMW, we had the situation that everyone comes, they do get a machine from the company, but it feels like the configuration for everyone is different. So it took them time to spin up the local machine, to set everything up with configuration and stuff. So we decided to just have an IDE in the cloud that they can just access in the browser. And that was that way it's much simpler for them. We have base Docker images that they can use, where a lot of stuff is already pre-installed, or they can also come in with their own Docker image Yeah.
And here you can actually notice, like, it's more noticeable how you can select a namespace, because this Kubeflow instance comes installed per BMW department. We'll talk about that a bit later, but essentially these notebooks and other resources are isolated per team in that department that then maps onto Kubernetes namespace.
Yeah. Okay. And I already mentioned it a couple of times, like, hey, okay, once you're like confident enough that what you have done makes sense, maybe beforehand you had it in a Jupyter notebook or only in your IDE, and then you want to start chopping it into pieces. Like you want to have maybe a step that does that, pulling the data from the central data hub, then you want to have another step that processes this data, you want to have model training, and then also maybe deploying it. And therefore we offer the users the Kubeflow pipelines. So yeah, I mean, it's something like Prefect or Airflow pipelines. I think you are kind of using that kind of pipeline stuff. And for Kubeflow, it's very nice because like every step is a Docker container basically under the hood. You can also pass data from one step to the next step, or you can save it on S3 as an artifact if it's like too big. And also you can have recurrent runs. Like obviously it's not enough to only train your model once, but you might want to retrain it on a weekly basis or on another cron schedule. And then also, conditional logic, like if you want to only run model training if the data is good enough, that's what you can do with Kubeflow pipelines. Anything else?
I would like to emphasize that you don't have to package your pipeline code in a Docker container beforehand. It's all handled, so you just write your code, structure it, so that different pipeline steps appear in different Python files and then gets deployed on the fly.
Yeah. And then you saw the Kubeflow pipelines, and then what we as a platform can also offer is like reusable pipeline steps. For instance, in Airflow, it's like operators, so they can just plug it into their pipeline, so they don't have to write everything from scratch. For instance, we are offering some features for model monitoring. So for batch prediction, they can generate some model monitoring reports, or they might want to send some messages to a Microsoft Teams channel. So we have a reusable component that they can just plug into their pipeline, so they don't have to write it up from scratch. Or also like to trigger AWS services. So that's how they also integrate with AWS services such as SageMaker processing jobs or Glue jobs if they want to go with the managed services, but of course they also have the capacity on the Kubernetes cluster. And then to also further facilitate them writing the pipelines and then also like uploading it to the Kubeflow server, we also have the Kupe SDK, which is, it's simply a Python package where we have gathered like the most important helper functions, and it's really like, it sounds basic. It's like AWS authentication, uploading them, triggering a recurring run, but it also helps them to just get started very smoothly. And so they can use the Kupe SDK either from their local machine or also from the CI/CD workflows. So they have both ways. There are data scientists, they prefer to just trigger the CI workflow, and then there are data scientists who prefer doing it from the local machine. And then, once the data scientist is confident enough, they either can obviously have a batch prediction model, which is pretty easy, then they don't need that much help. But for live serving it on the Kubernetes cluster, we are providing Kserve, and then also the car has access to the backend, like to the Kubernetes cluster in the backend. They can expose it as a model endpoint, as a REST endpoint. And on the so this is also a screenshot from the Kubeflow UI, where they can see all the metadata and how to access the endpoint from intranet or internet. Then what we also saw, that was an interesting feature because we haven't built it in right away, but we saw that a lot of teams, they have Streamlit dashboards. And for what? For situations where they still need to convince their manager, like they're having some POC, some EDA, and they want to convince their managers, hey, it makes sense to really invest in this model to further develop it, to bring it into production. And then they're easily making up some graphics or some sliding things where they can see how the model would work, because it's very easy with the Streamlit UI to showcase it to a manager or other product owners or peer developers. And the setup beforehand was that, I don't know, like singular data science teams, they were having some Terraform code that would spin up an EC2 instance, and then they would like manually SSH onto this EC2 instance to deploy their Streamlit app. And we saw, okay, that's a quick win there, we can help. So what now we as a platform are doing is to provide the Helm chart, and then also a CI/CD workflow that they can simply deploy to their Kubernetes cluster and don't need to boot up another EC2 instance on the side. And also all the access to the Streamlit dashboard is handled by us. And they are also using it for model monitoring, which they have match predictions. Yeah, and then the last feature I'm sharing is like the CI/CD workflow. So that's also something that helps them a lot. That they can simply, like, we have prepared some CI workflows, like, hey, how to deploy your pipeline to the Kubeflow instance, or how to build the Docker image and push it to the ECR repository. And therefore, we are using self-hosted GitHub runners. So there's a Terraform module by Philip Labs, and under the hood, it uses like Lambda functions to receive the event and then also trigger up EC2 instances and then trigger it down again if they don't need it any longer. And then there we're also using spot instances, which is also saving money. Yeah, that's it basically for the features. And we're also working on many more, like model registry and other stuff.
Right. In the next slide section, we're going to be talking about architecture. First, high-level overview of how or where the Connect platform fits. And our first layer of abstraction is AWS account, where we first have the platform of those like basic Terraform modules in Kubernetes that provides the basic functionality of networking, logging, and stuff, connected services cloud platform. On top of this infrastructure, we provision the Connect platform. And because we had a lot of frustration when we were talking about this topic, people thought that it was just like a one product available for everyone to use, but it's actually a product installed in an AWS account, or in an EKS cluster, to be precise. On top of this, we have machine learning applications that are owned, maintained by BMW departments, or as we call them, use case teams. And this structure persists across AWS accounts, but we'll later also talk about the mapping between staging environments and regions. This slide shows the features that Lena was talking about, but from the architectural or technology viewpoint. And here you can see the Cloud IDE notebook server, but you also see the helper managed services that we use for persistence under the hood. For example, S3, that is very common for data scientists. We also have Kinesis to work with real-time data out of cars. We also use Elastic MapReduce to provide a more cost-efficient solution for big data processing. And this flow is, again, I would like to emphasize that it's enabled end-to-end from WCL back to the WCL. And it's all, of course, subject to data privacy laws and customer consent. Important value point of the Connect platform is ensuring that the data that was collected in non-production stays in non-production. That's also like this importance of this point depends on a region where machine learning application is introduced. And in that regard, we are ensuring privacy and data isolation. It's embedded in the design of the platform, and it's also ensured by having separate AWS accounts for non-production and production. And we also provide tools that are actually already available at BMW for working with personally identifiable information. to not store it, not depersonalized at rest. In terms of how this infrastructure gets deployed, we naturally use Terraform, but on top of it, we also use TerraGrant and Helm. And the value of TerraGrant is to ensure that we can apply infrastructure at different levels, because we are dealing with multi-region and multi-environment deployments. And there are some resources that persist across environments and regions. And TerraGrant simplifies state management for such kind of resources. You can think of IAM role that grants access across environments or regions. Helm is used for simply packaging Kubernetes deployments and modularizing them. This flow is exposed via a self-service so that we don't become bottleneck in a way, with some quality gates and tests in between so that we don't have to do repeated work all over again. And in principle, use case teams can select which modules they would like to have in their connected platform installation. This infrastructure gets deployed, like I said, across environments and regions. And the default setup is that the connected platform cluster gets replicated in the same functional state across regions and environments. But use case teams can choose where. So this is just an example that a cluster is deployed in Frankfurt, Virginia, and Korea. And also like with 3 environments, but in principle, it can just be one region and non-production test and prod environment. And these clusters are shared by multiple teams to have some synergies. There are some shared resources, such as compute instances, that are kept for all the teams. But in principle, there are also teams that share their data, which is also possible to implement in this architecture.
Okay, so product management. I already shared it in the beginning. It's not that you can only throw it over the fence and expect users to just understand it out of the box, because obviously you as a developer, you have been working on this for a couple of weeks or months, so you understand it, but they are seeing it for the first time, so they do need some help and ramping up to really understand it and use it to the fullest. So also the last Thoughtworks Tech Radar also promoted to adapt this technique to really apply product management to internal platforms. And that's why we're also super happy to also have a dedicated product owner, because for, I don't know, either physical products or customer, like end customer facing products, such as a car or a drink, which is in the shelf in Rewe or Edeka, there's crystal clear you need product owners. But for internal software development platforms, it's first of all very hard to find those product owners who understand enough of the technique behind, but also to understand the user. And it's also like sometimes hard to explain to upper management, like, why do you need a product owner for this? It's just like some helpful functions for software developers. But luckily at BMW and Thoughtworks, we were aligned on this, that we needed. So that's what we did. And therefore we came up with the 2 streams. So at the beginning, we were starting with 1 stream, only the platform stream. But then over time, we have evolved to, once the product, so to say, was ready to roll it out, we also came up with the use case enablement stream. So yeah, the platform stream basically provides the main functionality, develops new functionality that where we know that, okay, all of the use cases needed. And we also we need to ensure the platform stability. And then also the use case enablement team, they are onboarding the use cases. They are also building maybe custom specific features, because as a platform, you don't want to be responsible to react to feature requests within the next week. But then maybe like the use case enablement team can first try it out and POC it with some use cases. And then once it's like really ready to roll it out to all of the platform users, then the platform team can take it over as a feature. Yeah, I personally am in the platform stream. Anton is in the enablement stream, but we both started in the same stream, which is the main platform stream. we do have a different kind of users at BMW. I don't know how it is in your company. We'll be interested to learn. But if we say like, okay, we do have a range of people, then on the left-hand side, we have these like super smart research scientists. Maybe they come with R or MATLAB, and they are like, they know everything about electric batteries and about the car and all the sensoric and videos, everything. They know it, but they are not that much interested in software engineering or how do I deploy it? Like, how will it be exposed so that it's accessible by the car? So we do have those users and we have to account for them. Also, we have, as DevOps engineers or architects, have to understand that it's also not interesting for them to become AWS experts or expert in object-oriented programming. So that's where we want to help. But then, interestingly, we also have users there, these like, I don't know, unicorn data scientists. They don't mind to write Terraform code or to use kubectl to just access their cluster on their own. So that's what we also have. So there, our platform also needs to be like flexible enough to allow for their kind of use cases, like that they want to use the Kype SDK in a shell script and not, only in Python. So we have to come up with strategies for all these kind of users. And the kind of strategies that we have, Anton will share.
All right, so that's a snippet from our actual onboarding deck, our contract with use cases, where it all starts with them requesting they are connected to installation. Then we move on to onboarding preparation, where we send out a checklist of our expectations, where they are expected to have all sorts of access to be able to assume all the IAM roles that we provide. They also are expected to install tools and make sure that the Python version that they have is compatible with the tools that we are providing. And importantly, the goal of the onboarding session and also the checklist is for them to be able to run our so-called first example pipeline that is just model training and data transformation, very simple. And in the onboarding session, after we are done with this checklist on the use case side, we do the walkthrough over the features and UIs that we provide that they can use in their setup, also focusing mostly on the features that they would be interested in, depending on how far they are in their machine learning journey. If they are in pre-development phase, they would use notebooks. If they already have a production-ready solution, we would instead migrate that solution. But I'll talk about that a bit later. We also share the context, and we, as the enablement stream, get the first perspective of the use case, because the work done before they request their installation is done by our product owner. And we are also discussing next steps and any unforeseen dependencies, so that while they have their continuous onboarding, we can take care of those dependencies, maybe as extra features or spike topics on our side. After the onboarding session, we move on to the support phase, where technical ad hoc requests are answered in a dedicated Teams channel. We are also trying to reduce these requests by documenting them in our Confluence Q&A. And the most interesting part, at least personally, is the architecture and MVP or proof of concept sessions that we provide to use cases, so that we can shape their connected architecture in a way that would have the impact to the end customer early on. And that would also allow us to slice the work in terms of what's valuable to us, what we would learn as the platform from their use case. Maybe we can collaborate on next new feature together. That's what actually happened for this EMR on EKS. And once this initial phase of first 8 weeks, let's say, is over, we are still open to use cases contributing to our Confluence Q&A, and we also provide weekly walk-in Q&A session. And there is a bunch of challenges with this process. It's also not a silver bullet, but we try to structure it as much as possible. That's the pipeline I introduced that we use in the onboarding session and also in the checklist. It's wrapped as a copier or Jinja template that is very simple, where people need to provide their use case specific values. And out of this template, they get simple pipeline Python module or application. And this application is abstracted away from these use case specific values wherever possible, so that the same machine learning logic can be deployed to a further environment or different cluster in case we need to migrate for any reason, and also enables CI/CD deployment of the same pipeline across environments and regions. And of course, that simple pipeline is not sufficient. It's just to showcase what's possible on the Connected platform. For that, we maintain, for further development, we maintain a dedicated repository that follows the same structure that we provide in the simple repository. And in principle, they can copy a common scenario that we discovered with other use cases in their simple pipeline and be able to adopt that example, for example, for batch inference, for data quality, and drift detection, Glue, other managed services, and Spark EMR NICs. How we collaborate with use cases after they are onboarded. It's also not a very structured process, but at least the way how we envision that is that there are at least two high-level collaboration modes where we are either migrating an existing solution, for example, a managed service heavy pipeline, and we did some work with promoting the Connected platform at BMW, and they decided to go for it. And we would like to migrate it first before starting to optimize it from the get-go. And the second one is when a use case that is done with exploring their data in Jupyter notebooks, or at least understanding the domain and variables, or the model that they envision on paper, and they would like to make it production ready. We devise this architecture from scratch, accounting for all the dependencies and edge cases, but not from the get-go. And in both, we strive for a minimum viable product or proof of concept, depending on, again, how far use case is in their machine learning journey. To close off, we'd like to provide some links. I'm not sure why I can't go further. Can you? Right. Okay. I found it really useful to refer to Kubeflow Slack community because we have quite a setup. It's multi-user, multi-namespace, multi-cluster with shared resources. Of course, these edge cases are not documented, so we had to do our own trial and error. Sometimes we also weren't understanding the application well enough. That's why we reached out, and actually it was surprising to find answers to our questions in the Slack community. It's also exciting that Kubeflow was now accepted to Cloud Native Foundation Incubator. So the first link indicates that the product is not yet mature, but the second one indicates that it's has high potential. In terms of AWS, we would like to highlight that even though we are using managed services, they're not documented to the extent where it would be just for us to sit down and implement it. It also involves multiple iterations of trial and error. especially for AWS Glue and EMR, and especially for cost and how this cost gets accumulated. And also, we would like to offer the quotes, our favorite quotes from Pragmatic Programmer that reflect our experience on this project. First, we think we care about our craft, and that actually helped us to, from our perspective, succeed. And just realizing that things will take time and are difficult and should be difficult already gives us the grit to keep at it. And from Lena, we should be careful about reading error messages and be able to reproduce issue reported by a use case developer before we start looking into it. That's it.